Number 10. Which quadrant are we in for number 10? Quadrant 1. So there's my triangle. And cotangent, remind me what cotangent is? It's adjacent over opposite. So 2 over 1. I already put it in. So if this is theta, and 2 is adjacent, and 1 is opposite. Everybody agree? So what is the tangent of that same angle? 1 over 2. Opposite over adjacent. I didn't need to find h in this case. And actually, did I even need to do that? No, because tangent and cotangent are reciprocals. So I could have just taken 2 over 1, and took the reciprocal, flip it upside down, and get 1/2. They're not all going to be that easy, but some of them are. Okay. Number 12. The secant of theta if the tangent of theta is -2. Which quadrant are we in? Quadrant 2. So Brooklyn, in quadrant 2, we make this triangle, because it said it's between 90 and 180. Got that? Well, tangent is opposite over adjacent, which is equal to -2 over 1. From there. But which one is actually negative? The opposite or the adjacent? Yes, this is 12. Well, in quadrant 2, this is adjacent and this is opposite. Which one gets the negative? The adjacent is -1 and the opposite is 2. Do you understand why that's the case, Brooklyn? Okay, so just because it says -2 over 1, that doesn't tell you where the negative goes. The quadrant tells you where the negative goes. And if it's in quadrant 3 and the number is actually positive, then they're both negative. Okay, so if you had a tangent in quadrant 3 and it was 1, it would be -1 and -1. Okay, so I want to know the secant. And the secant is h over a. Do I have the necessary information to calculate the secant? No, I need to calculate h. And just a comment on the length of h, it's always longer than the other two, and it's also positive. The hypotenuse on the unit circle is always positive. Okay? So, 1 squared plus 2 squared equals h squared. Everybody okay with that? Yes? So 1 plus 4 equals h squared. So h squared equals 5. So to find h, square root, and I get plus or minus. Which one is it? In this case, it's plus. So h is √5. So I can go back to my triangle, and I can label it as √5. And the the secant is h over a, which gives me is -√5, or -√5, √5 or -1. Either way, that works. Okay, let's do, yep. So it's just what we did yesterday, but you don't have to use the nasty formulas that we used. That's the only difference. So we should have done this first, but I'm not that smart, so this is just what you get. Okay, let's do 14. Which quadrant are we looking at for 14? Quadrant 2. So I draw my triangle in quadrant 2. And if the cosine is negative 3 over 5, where do I put those? 5 is the hypotenuse, and I know that 5 has to be positive, which means the ground, the adjacent side, is going to be negative 3. Okay? But this is a 3, 4, 5 triangle. So the opposite side is going to be 4. But is it positive 4 or negative 4? Positive, because we're in quadrant 2 and the y value is positive in quadrant 2. So we're going to put a 4 here. Cosecant, what is the ratio for cosecant? H over O, and that's on your worksheet, your reference sheet. So in this case, it's going to be 5 over 4. That's it. All right. That'll get you through the first section. The second section asks you to simplify expressions. And this is actually kind of fun. It's one of the things that I like about trig. It's problem solving, and there's really not one way to do it. So look at your formulas. Oh, hopefully I saved it. There we go. Okay, these formulas here. Who knows? Maybe we should just close the door. He gets a little excited in the afternoon. Okay, do you see those formulas? They're on the right side on the left column, but near the top. The tangent and cotangent identities and the reciprocal identities. So what this is going to give you is a random expression using trig. And then it's going to ask you to simplify. What it means is use substitution to make that problem smaller. Uh-oh. Maybe I don't have another example. I'd better. Oh, okay, here we go. Nope. That's not going to do it. Oh, come on. Hang on a second. That's not it either. Okay, here we go. So what if I had cosecant of theta, cosine of theta, and tangent of theta? Can we make that easier? Can we make it smaller? And usually you want to turn everything into sine and cosines and then cancel what you can and then convert it into whatever's going to make it the smallest. So what I would recommend is go through and change it to sines and cosines. Can I put cosecant in terms of sines and cosines? Right here. 1 over the sine. And I'm just going to stop writing theta because they're all theta, so we're just going to ignore it. 1 over sine. Cosine is already written in that form, so I'll make it cosine over 1. Can tangent be written in terms of sines and cosines? I could turn it into a cosecant, but my recommendation is avoid cosecant, secant, and cotangent. Turn it into sines and cosines, and then you'll be able to simplify, and then you can convert it back if necessary. So sine over cosine. Does anything cancel? Cosines cancel. Sines cancel. The ones cancel. So the answer is 1. So if you had the cosecant of 10 degrees times the cosine of 10 degrees times the tangent of 10 degrees, the answer is going to be 1. And if you change that 10 degrees to some other angle, it's still going to be 1. So whenever you have cosecant times cosine times tangent of the same angle, it's just 1. Okay, here's another one. What about tangent of theta over the sine of theta? I recommend that you convert everything to sines and cosines. So I'll use this formula to convert the tangent. Sine over cosine over sine. And there's a difference between little divides and big divides. Okay? The big divide divides the whole little divide. Sometimes that happens. Okay, well, can we make that easier? How do you divide two fractions? But this one's not a fraction yet. So put it over 1. So now we have two little divides and one big divide. So I flip it, 1 over the sine of theta, and sines cancel, and I get 1 over cosine, which is also known as secant. So this equals the secant of theta. You want to see another one? Oh, shoot. This other one is not one that I want to do. So let me make one up. Let's do cosecant of theta times the secant of theta times the tangent of theta. Okay? So 1 over sine times 1 over cosine times sine over cosine. So the sines cancel, and I get 1 over, what's cosine times cosine? Cosine squared of theta. And we write it this way. Cosine squared of theta. Well, 1 over cosine squared has to be the same as, can I convert this? Secant squared of theta. And that would be considered simplest form. Do you not get that? Where did you get confused? Well, it's 1 over cosine times 1 over cosine, right? Which is secant times secant. Right here. And then it's really secant of theta squared, right? But if I'm too lazy to write the parentheses, so it would be secant of theta squared, but that's something different. There's a huge difference between secant of theta squared, which does not equal secant of theta squared. Do you see the difference? In the first one, we're squaring the secant, but in the second one, we're squaring theta. So to avoid that and to not have to use parentheses, we've moved this exponent inside between the secant and the theta. And that's how everybody writes it. So there are a lot of formulas on there. You'll see sine squared of theta or cosine squared of theta. Now there are a lot more identities that we're going to get to later. We don't have time. Well, we want to do other things. So that should get you through this whole worksheet. Yeah, it should. And again, you're not doing 22, 23, or 25 through 28. And I have the odd answers only at the moment. So there are the odd answers. 24. Yeah, I'll do 24. So cosine theta cosecant theta over tangent of theta. So cosine we leave as it is. Cosecant is 1 over sine. Well, when I multiply those together, I get cosine over sine, but cosine over sine is also known as, oh, I lost the, cosine over sine is the cotangent. So I have cotangent divided by tangent. Well, let's convert them all to sines and cosines. So cotangent is cosine over sine, and tangent is sine over cosine. How do you divide two fractions? Flip and times. It is, no, it's sine cosine over sine cosine. Or, also known as 1. Oh, did I? Cosine, oh, I'm sorry. I'm sorry, I wrote that wrong, huh? So cosine over sine, and then sine over cosine, and then you flip it, thank you. So cosine over sine, which is cosine squared over sine squared, also known as, what's cosine over sine? Cotangent, so it would be cotangent squared. Now, there's another way to do this that might have been a lot easier. If I get to this step, can I write tangent in terms of cotangent? So I have a cotangent over the tangent. But if I flip that, it would be 1 over the cotangent, right? Well, if I put this over 1 and I flip in times, then I get cotangent over 1 times cotangent over 1, which is cotangent squared. Now, those are going to get a lot more complicated in about a week. I mean, really complicated. But they're not nearly as hard to do as that stuff that we did yesterday. Because all you have to do is a little bit of substitution, and if it doesn't work, then go back and try a different substitution. You don't have to work through the hard things. They are all pretty easy. You just have to find the right combination to make them easy. Okay. Now you can get to work.